Here is the lesson plan for Tuesday, December 3rd. This video will include the notes that the substitute teacher will hand out to you. Fill them in as you watch the video. And it also includes the homework assignment that we do on lined paper. The video will explain how to do those problems if you need the help. Make sure you turn your assignment in to the substitute teacher before you leave class. So first thing today, start with the bell work like you always do. Spend some time, maybe up to the 7 minutes, and work on the IXL for today's date. Don't forget to do that. After that, the substitute teacher will give you the note page for lesson 4-7 about transforming formulas. It looks like this. Number 1, read the intro paragraph on page 165 of the Chapter 4 textbook. Formulas are used in many applications of mathematics. Example 1 uses a formula from automotive engineering. It is often helpful to transform such a formula to express a particular variable in terms of the other variables. We have read the intro paragraph. Number 2, read example 1 from the textbook. A formula for the total piston displacement of an automobile engine is P equals 0.7854 d squared Sn, where d is the diameter of each cylinder, S is the length of the stroke, N is the number of cylinders. Solve this formula for the variable S in terms of the variables P, D, and N. And then you see where the authors have done that. They started with the formula given in the story problem, where the letter P is alone on the left side of the equals. And then they've described how to get the variable S to be alone on one side. Divide both sides by all of those other things that have been multiplied to the S. And at the very bottom of the screen, you can see the result. This is an equivalent equation to the one in the story problem describing the automobile engine, but it has a different variable alone. The letter S is alone, and all the other things are on the left side of the equals. We have read example 1, check. Number 3, true or false? The math formula in the story relates the total piston displacement, the diameter of the engine cylinder, the length of the piston's stroke inside the cylinder, and the number of cylinders in the engine. Was that what that math formula was giving to us? Yes, true. Every one of the variables in that formula was representing one of these things, like total piston displacement, diameter of the cylinder, and so on. Number 4, true or false? The formula in example 1 has been solved for P, meaning that it finds the total piston displacement. Taking a look at the formula that was given in the original story problem, yes, it has the letter P alone, and we're told in the first sentence that the letter P is representing total piston displacement. So number 4 is true. Number 5, true or false? By transforming the formula so it's solved for the variable S, the equation can be used to find the length of a stroke based upon the value substituted for the other variables. Yes, true. The variable S, we were told, was representing the length of the stroke. Number 6, read example 2 on page 165 of the textbook. What variable is alone in the formula given in that example? Here's example 2. Solve the formula for the variable shown in color. The formula is A equals S squared plus 2RS, and then in red ink it says solve that for R. But what I'm asking you in the notes page is, what is the variable that it has been solved for initially? What variable is alone? And that's the capital A. So number 6, the variable is the capital A. Now still number 6, after the transformation, what variable is now alone? So we were asked in example 2 to solve for the variable R, the one shown in red ink, the letter R. The authors have shown the solution. It takes a couple steps of work, but then right here where it says the word answer, we see that the letter R is now alone, so that equation has been solved for the variable R. So in number 6 on this blank is the letter R. Number 7, true or false. To transform a formula so that a specified variable is alone, you perform the same equation solving steps that you did in chapter 3. That is, you remove added terms by subtracting them, or you remove subtracted terms by adding them, or you remove divided values by multiplying them, and so on. That is true. Number 7 in bold ink is giving you the main idea of today's lesson. We're going to transform formulas to get a particular letter of the alphabet alone, and the way that you accomplish that is do the same steps that you did in chapter 3. Now let's try some of these. Number 8, solve for the variable x. So we have an equation, b is equal to ax. At the beginning, the variable b is alone. Let's transform this equation to get the letter x alone. Find the x. What's next to the x? The a. The a has been times to the x. What is the inverse operation of timesing by a? Dividing by a. So we've made a decision that to get the variable x to be alone, we want to divide by a. That's going to create b divided by a is equal to x. And now the letter x is alone. This equation is equivalent to the original equation, but instead of being solved for b, it's solved for x. Now number 9, solve the equation for the variable r. So initially, the capital C is alone. We want to get the letter r to be alone. So you might think that you just need to get rid of the m and the v squared, and then the letter r would be alone on the right side of the equals, but that would result in the letter r being in the denominator, and that's not what we want. So the first thing we're going to do is multiply both sides by r. That will create c times r, and that will be equal to mv squared. The letter r has been moved from the right side of the equals where it was in a denominator to the left side of the equals. Now we want to get the letter r alone. What's next to the r? The capital C. The capital C has been multiplied to the r. What's the inverse of multiplying by c? Dividing by c. So we've made the decision that to get the letter r alone, we want to divide by the capital C. So r is equal to mv squared divided by capital C. Question 10. Solve for the variable v. Right now we have a math formula with the letter a, the letter v, the letter u, and the letter t. That formula has been solved for the a. We want to transform it so the letter v is alone. Well, first, let's remove that dividing by t so that there's not a denominator with a t. We can do that by multiplying by t. So we have a times t is equal to v minus u. We're trying to get the letter v alone. Find the v. What's next to the v? Subtract u. What's the inverse thing of subtracting u? Adding u. So we make the decision we're going to add the variable u. So we have a times t plus u, and that will be equal to v. We've transformed the equation so that now the letter v is alone. Number 11, solve the equation for the variable n. There is an L, there's an A, there's an N, there's a D, there's even that -1. We want to rearrange it so the letter N is alone. I notice that the letter N is contained within parentheses, that is multiplied by D, but there's also a plus A. So I want to be careful with the order that I remove things. First step, subtract the A from both sides. So L minus A is equal to N minus 1 times the D. The letter N is the one we want to get alone, but it's trapped inside the parentheses. So we want to remove the parentheses. We can do that by doing the distributive property, Or even faster would be to divide both sides by the d. So L minus A divided by d is equal to n minus 1. With the d gone, there's no need to have parentheses around the n minus 1. Now, one more step, the letter n will be alone. Can you figure out what you need to do? How do you get rid of that minus 1? You add 1. So L minus A divided by d plus 1 is equal to n. We've rearranged the equation so that the variable n is alone. Okay, so that was filling out the notes page, and we can see the main idea of today's lesson is that we'll be given an equation that has more than one variable letter in it, and we'll be asked to solve it for a particular letter. And that's done by transforming the equation, removing things from one side until you get the letter alone that you're looking for. Here's the assignment for lined paper. So same as always, grab yourself a piece of lined paper from up front, write down the header at the top, do these odd problems, and staple it to your notes and make sure you turn it into the substitute teacher by the end of class. If you want some help doing these, or you just want to know if you get the right answers, then keep playing the video. Here are the worked out solutions to the assignment. Number 1, the circumference of a circle is equal to 2 times pi times the radius of the circle. Solve for the radius of the circle. We want to get the letter r alone. Find the letter r. Here it is. Now what's on the same side of the equals as the r? That would be the 2 and the pi. And the 2 pi is times the letter r. There's not a dot there, but you could think of it as having a dot there if that helps you. How do you remove 2 pi if it's been times to the r? What's the inverse of timesing? Dividing. So we make the decision that we're going to divide by the 2 pi, and that would make the letter r be alone. So c divided by 2 pi, and that's equal to the letter r. When you're in geometry class and you want to find the radius of a circle, you take the distance around the outside and divide by 2 pi. Number 3, S equals V divided by R. Solve for R. We had one like this in our notes where the variable we're solving for is trapped in the denominator. So what you do is you multiply by that to move it to the other side of the equals. Let's multiply both sides by R. We get S times R is equal to the letter V. Hey, if we were asked to solve for V, then we've done it. But we're asked to solve for R, so one more step. Divide by S. So we have R is equal to V divided by S. Number 5. The interest on an investment is equal to the principal times the rate times the time that the money is invested for. Solve for the principal. We want to solve for capital P. So find the capital P. Here it is. What's next to the capital P? The R and the T. And the R and the T have been multiplied to the P. What is the inverse of multiplying by RT? That would be dividing by RT. So we make the decision to divide both sides by RT. We get I divided by RT is equal to the capital P. Number 7, A equals 2a squared plus 4ah. Solve for the variable h. And please notice that there's a capital A and there's a lowercase a, and those variables are representing different things. We want to get the letter h to be alone, so you got to find it. Here it is. Multiplied to the letter h is a 4a. And that can be removed by dividing. But that term has something else added to it. And we know from chapter 3 that the first thing you got to do is isolate the term that has the variable in it. So we first got to get this to be alone by removing the 2a squared. The 2a squared has been added to the term with the h. The inverse thing of adding is subtracting. We need to subtract the 2a squared. Now we have the 4ah alone on the right side of the equals. We want to get the letter h alone. Well, there's a 4a in front of it. How do you remove that 4a? By dividing by 4a. So we get a minus 2a squared divided by 4a, and that is equal to h. Number 9. The area of a trapezoid shape is equal to 1/2 times the height times the sum of the top and bottom of the trapezoid. Solve for the height of the trapezoid. We want to solve for h, this one right here. We need to remove the 1/2 and remove the a plus b. Let's remove the 1/2 first. Think back to chapter 3. How do you remove a fraction that's multiplied in front of the variable? You multiply both sides by the reciprocal of that fraction. The reciprocal of 1/2 is 2. So the first thing we do is we multiply both sides by 2. It's going to make 2 times the capital A. And on the right-hand side of the equals, we get h times the a plus b. We're trying to get the letter h alone. What's next to it? The a plus b has been times to the letter h. How do you remove something that's been timesed? By dividing by it. So we make the decision to divide by the a plus b. So 2 times capital A divided by a plus b is equal to the h. Number 11. The perimeter of a rectangle is equal to 2 times the sum of the length and the width. Solve for the width of the rectangle. We want to get the letter W alone, but the letter W is trapped inside the parentheses. There's 2 things we could do. We could do the distributive property, that removes parentheses, or we can remove the 2 by dividing. Because the 2 has been times to the parentheses, if you divide by 2, the 2 will cancel away, and there won't be any need for the parentheses. So P divided by 2 is equal to L plus W. We're trying to get the W alone. How do you get rid of that L? That L's been added to the W. How do you get rid of it? You subtract it. So we have P divided by 2, subtract the L is equal to W. Number 13. The mean or average of 2 numbers is equal to the sum of the 2 numbers divided by 2. This finds the number right in the middle of whatever x and y are, and that's called the mean or the average. We want to solve for y. Here's the letter y. Let's remove the denominator of 2 by multiplying by 2. This makes 2 times m is equal to x plus y. We're trying to solve for y. What's next to it? The x. The x has been added to the y. How do you remove the fact that x has been added? By subtracting the x. So 2m subtract x is equal to y. Number 15. S equals n divided by 2 times a plus l. Solve for a. Well, here's a. It's trapped inside the parentheses. To get that a alone, we're going to have to get rid of the parentheses. Now we could do the distributive property, that removes parentheses, or we can remove the n over 2. If the n over 2 is not there, then there's no need for the parentheses. So let's multiply both sides by the 2. That makes 2 times s is equal to the n with the parentheses a plus l. Now let's get rid of the n. The n has been timesed in front of the parentheses. We can remove times by n by dividing. So 2 times capital S divided by n is equal to a plus l. We're trying to get the a alone. How do you get rid of plus l? So we make the decision to subtract l. So 2 times capital S divided by n, subtract l, is equal to a. Number 17. A equals v minus u divided by t. Solve for t. Okay, the variable we're trying to solve for is down in the denominator of a fraction. This has happened before. So first thing, multiply by that t. A times t is equal to v minus u. Now we can get the t alone on the left side of the equals if we get rid of the timesing by a. So t is equal to v minus u divided by a. And number 19. V squared equals u squared plus 2as. Solve for s. Well, you got to find the letter you're solving for. Here it is. What's on the same side of the equals as that letter? Well, there's a 2a multiplied right in front of the s. That's going to be removed by dividing. But this variable term that has the s also has another term added to it. So we know from chapter 3 that you first get the term alone that has the variable. We got to get the 2as alone. We can do that by subtracting the u squared. So v squared subtract u squared is equal to 2as. Now we can get the letter s alone. How do you get rid of the 2a, which is written right in front of that s? You divide by it. So v squared minus u squared divided by 2a is equal to the s. This concludes the assignment that goes along with the lesson notes.